We're given the mass, we're given the length, we know there is US and UK given, and this time there is friction everywhere. On the floor and on the wall. This is problematic because then we know that we're going to have way more unknown. Normal force between the ladder and the floor, friction between the ladder and the floor, and then 2 more on the wall. That's 4. Oops. Do we have to use the metric? I'm sorry, Ray. I didn't look my other screen. Were you at this stage? And I'm sorry I missed this, but did I eventually answer your question, Ray? Or does your question still apply? My bad, but made me move that stupid computer in front of the chat. There we go. Ray, are you still with us? Did your question has been answered, or is it still relevant? I'm sorry that I missed it. Or are you asking about this new problem? Or were you still in the old? Nope, you don't. Remember, we've seen 2 methods to calculate the torque. The 2D method and the 3D method. The 3D method is the matrix method and a determinant. But you can pick any method you like. I will not force you to use a specific method. What I've been saying is, if you are going to CE and ME major, you definitely want to master the matrix method because that's the only one you can use in 3D. But in 2D, you can go either or. The 2D method is about identifying the component of the position vector perpendicular to the force, or identifying the component of the force perpendicular to the position vector, depending on what's given to you. So you decide. Perfect, perfect, perfect. So this case, very similar, except they're asking us if the system is at static equilibrium, what is alpha min for the system to remain in static equilibrium? I'm sure that if you have played with pencil, maybe not the ladder, but a pencil, and you try to put a pencil like this, you know that there is an angle. As you're going to decrease the angle of alpha, eventually your pencil is going to slip. So there is a minimum value for that alpha for the pencil to remain like it is. Same thing with the ladder. That's very good news because let's do a free body diagram and let's confirm the problem that we had. If the mass is given to us, we have to consider the mass and specifically the weight. 2 normal forces again, N prime. But since there is friction, again, the tendency of point A is to go left. Therefore, Fs is right. Let's call it Fs prime. And similarly, the tendency of point C is to slip down. Therefore, there is a friction here. And it's a different friction from the one at A. That's where we realize we're stuck. There's 4 unknown: Fs, N, Fs prime, N prime. What is the keyword that saves us? How can we minimize the number of unknown? Remember the method when you deal with friction. Is there a keyword that is right in the middle of the page that will allow us to reduce the number of unknown? Right now we have N, Fs, N prime, Fs prime, and alpha. We have 5. We need to go back to 3. If this doesn't come to mind within 10 seconds, then you need to review. Nope. We already know it's a static equilibrium, which tells us that we can use Fs. We agree with this. There is something else. If we only use the fact that it's a static equilibrium, we have 5 unknown. There is no way we can solve it. We need to bring it back to 3. close, but do you see those keywords listed on the board? Or did I say them early? Oh, I guess I said them early. Yeah, minimum. That's the question that 90% of you missed on the last 2 quizzes. So please review the technique for friction. When you are dealing with friction, you know there's friction, you have 2 questions to ask yourself, or 3. First, is your system moving or not? If your system is moving, you know you have to use FK, not μk, FK. And then you substitute FK by μkn. If the system is not moving, that is, you see the keyword equilibrium or at rest, specifically at rest, then you know that the system is not moving, therefore you have to use FS. And then you have to look at and getting more information about the tendency of motion to figure out the direction of that stupid FS force. And now that you are in a case of rest and you know you have to use FS, you have to ask yourself a third question, which is, do I see the keywords minimum, maximum, about to move, or range? If you see any of those 4 keywords, then you know that FS is max. Therefore, this becomes FS max, which means that finally you can replace this by mu s n, and this one mu s n prime. Exactly, for both of them, which now reduces 5 unknown back to 3. And that's it. Minimum, maximum, range, about to move. Range is overkill because a range implies a minimum and a maximum, but just to be sure. And about to move is 1 keyword. About /to /move. So if you see any of those, minimum, maximum, about to move, range, if you're not sure, re-watch the recording on Zoom. We went through this step by step. So go back to that lecture or that archive and update your notes. Very, very important. That's going to follow in C270, C271. Perfect. So now we're back to solving this problem easily. N prime, alpha are the only 3 unknown. Easy. Let's pick coordinate system so that it's also centered at A. Let's apply Newton's first law. In translation, sum the forces equal to 0. Again, trivial, negative n, positive, mu s n prime is equal to 0. In the y direction, mu s n plus n prime minus mg is equal to 0. The last one, sum the torque is equal to 0. We expect 1, 2, 3, 4, 5 terms because we have 5 forces. Correct? But we've positioned our current system at point A, which implies that I'm going to calculate the sum of the torque about point A, which means I just got rid of 2 torques, the one due to n prime and the one due to mu s n prime. Therefore, I only have to consider 3 torques. But again, n and mu s n are applied at the same point. Therefore, they share the same position vector, which means we can combine those 2 matrices into one. Therefore, we really only have 2 torques. And that's it. Now the rest is math. Back to chapter 2. Negative mg, that's easy, 0, 0. Negative n plus mu s n, 0, 0, 0. And now back to chapter 2, simple geometry. If we know the length L, then this is L over 2 cosine alpha, L over 2 sin alpha. And the last one is just double that. L cosine alpha, L sin alpha. That's it. So from this, we can extract the third equation, which is negative L over 2 mg cosine alpha. Okay. The next term is positive, L mu s n cosine alpha. Okay. And then positive again, L and sin alpha. And now we can solve for alpha. We can clean it up a little bit. K shows up everywhere. Now we got our scalar equation. L is everywhere. And we've done this in previous quiz. You've practiced this. How are you going to solve for alpha here? You remember, we're going to combine those two. You're going to move this one on the other side. You're going to divide everything by cosine. Bang, done. Easy.